We are still practicing on the unit circle. So grab this piece of paper that you got when you came in, all right? And in this first circle right here, in this first quadrant part, rather, this right here, I'm going to give you about a minute or so. On here, I want you to write, without looking at anything, okay, digging it out of your brain, I want you to write in the radians for each angle here and each of the ordered pairs, okay? Go. Don't tell me no. All right, that was 1 minute. You should be able to do it in under a minute. So double check yourself with me up here. Make sure that you got it down right. This angle measure that's 0, I should have been doing 0 and 2 pi like the whole time. I mean, in the first quadrant, technically it's only 0. It's not 2 pi, but that was a question on Friday, and so probably every time we put 0, it could be 0 or 2 pi. So, I mean, they all have other names we could call them. So are we good on that? We got the first quadrant down? Yes? Awesome. All right, so now I want you to go to your second first quadrant, the one right underneath it. And on this one, I want you to fill in the radian measures and then the tangent values to the best of your abilities. All right, make that happen. And I didn't tell you you had to know your tangent values today. I said today you had to know your first quadrant angles and your ordered pairs, your sine and cosine values. But let's just see what we can dig out of our brains for tangent, okay? All right, so there's two different ways we could get tangent, right? And you have to remember, even with the first quadrant that you just did with your sine and cosine values, you're not always going to have to do the entire quadrant or the entire circle. So you do have to have ways to know the pieces. I'm going to do this one way, then I'm going to erase it, and then we'll talk through another way. So if I had to put in the entire quadrant like I just asked you to, you could use the little phrase I gave you, which is the U are one really overwhelming third wheel. So that U would be undefined. R is the square root of 3, 1 is 1, really overwhelming third wheel, okay? They're my tangent values. But again, if I don't have to do the entire quadrant, I probably don't want to have to think through all of that if I just needed pi sixths or something like that, okay? So I'm going to erase that. They're not wrong, but then I'm going to redo them. We know that we know that tangent is sine over cosine. So if this ordered pair here is 0, 1, which it is, and I put sine over cosine, that's 1 over 0. Well, 1 over 0 is undefined. This ordered pair is 1, 0. When I put 0 over 1, I get 0. This ordered pair, square root of 2 over 2, square root of 2 over 2. When you put something over itself, it reduces to 1. So there's really only these two values that we have to remember, and they both have the square root of 3 of them, right? One of them is the square root of 3, one of them is the square root of 3 over 3. 6 takes 2 3's to get to 6, so we're going to have the square root of 3 over 3. It has 2 3's in it, and the one with 1 3 just has 1 3 in it. Okay, so however you remember it, I kind of think both ways because it depends on when you need to know it, but that's it. Okay, we're good with tangent? We got that? Awesome. Now flip it over. Then you have a blank circle. So I'm going to give you about 5 minutes or so, maybe a little bit longer. And I want you on here for the entire circle, to the best of your abilities, without looking at anything else or cheating off your neighbor, write in all of your radian measures and all of your ordered pairs. Stop it. Just see what you can dig out of your brain. Just because I felt like it was too much when we wanted to write it inside of it. Okay. Yeah. I mean, you can draw the lines in if you want to, but yeah. Plus, when you really have to know it, you're not even going to have the circles, so I was trying to minimize what was always right in front of you. Once you get the first quadrant down, the rest should be pretty simple, right? Such a complainer. That looks good so far. Yep. Okay, I'm gonna go ahead and put mine up there so you can check yourself. It's a lot to look at, but I mean, once you can double check the signs, you see all the reflections and all that good kind of stuff. Should hopefully be pretty simple. But remember, you're not always going to be asked for the entire circle. You might be asked for instance, what's the sign of 7 pi sixths? Is sign X or Y? It's Y. So it's -1/2, right? And so that's something we want to know without having to write out the entire circle. That's where our hand trick's going to come into play and a couple other things. All right, what is the cosine of 3 pi fourths? Negative square root of 2 over 2, exactly. 3 pi fourths, cosine is your X value, right? Are we good on all that? Okay. Hopefully, again, do you understand how if you get the first quadrant down, then we can get the rest down? We learned how to think through these angles in the second and third quadrant to get them labeled correctly. We'll talk about that a little bit more here in just a second. Okay. So everybody good on this one? All right, so just looking at my blank one, so don't look at your stuff, just look up here. Remember, if we want to think fractionally, that's going to help us figure out what quadrant our angles are in. Because if I ask you for the value of, sine, cosine, or tangent of any angle, the first thing you're going to want to know is what quadrant is that angle in. So if I ask you about 7 pi 6, well, when you get to pi, this is at 6 pi 6, right? So 7 pi 6 is in which quadrant? The third, because I'd have to go forward one, right? 5 pi 6, I would have to back up one. Yes? All right, so what quadrant is 3 pi fourths in? Second, because this will be 4 pi fourths, 3 pi fourths is in the second quadrant. What about 5 pi thirds? The fourth, because this will be 3 pi thirds, this will be 4 pi thirds, right? Then 6 pi thirds, we back up one to get to the 5, all right? What about 5 pi fourths? The third quadrant, right? What about pi thirds? First quadrant. If the numerator is just a pi, it's in the first quadrant. All right, what about 3 pi halves? Okay, so what kind of angle is it? What's that word? Remember if it lands on an axis, because it is right here. It's quadrantal, right? It's a quadrantal angle, and it's on the negative y-axis. All right. What about 4 pi thirds? Third, because this would be 3 pi thirds, 4 pi thirds, right? Okay, so if I know that, let's say I ask you for the cosine of pi 6, right? So pi 6, you can use your hand trick. Here's pi 6, right? So the cosine is what? Of just pi sixths? Square root of 3 over 2, right? So if I know that, if I use my hand trick, I know for pi 6, which would be my reference angle, is square root of 3 over 2. 5 pi 6 puts me in which quadrant? The second. 5 pi 6 would put me right here, right? So I'm in the second quadrant. Is the x value positive or negative in the second quadrant? Negative. So the cosine of 5 pi 6 is just negative square root of 3 over 2. The quadrant's going to help you with the sign. But I'm going to help you figure out the sign even easier. The sign meaning S-I-G-N, not the S-I-N-E. Instead of having to think, is the x and y positive or negative? Let's look at what else we can do with that. So on this blank circle that you have, so your next blank circle, we're going to label our quadrants. First, second, third, fourth. Right. And we know that when we plot points in the first quadrant, it's always positive, positive. Second quadrant, it's negative, positive. Third quadrant, it's negative, negative. Fourth quadrant, positive, negative. Right. Then we know for our ordered pairs that it's always cosine theta, sine theta. It is alphabetical, just like x and y is. And we know that tangent theta is it sine over cosine or cosine over sine? Sine over cosine. Okay. And it's always, even though I'm just saying cosine, it's always cosine theta or sine theta. You always have to take the sine, cosine, or tangent of something. Right? So if we know which trig values are positive in a specific quadrant, then we know the other ones have to be negative, right? Well, in the first quadrant here, we have everything's positive. Sine and cosine are positive, so when I make tangent, it's going to be positive. So they are all positive in the first quadrant. In the second quadrant, my y value is positive, so which one is that? Sine, cosine, or tangent? Sine, right? And when I create tangent and I put sine over cosine, is it going to be positive or negative? Negative, and so is cosine. So the only sine, cosine, and tangent, the only one that's positive in the second quadrant is sine theta. When I go to the third quadrant, sine and cosine are both negative, so what does that make tangent? Positive. So tangent theta is positive. In the fourth quadrant, x is positive, and which one is that? Cosine. Is tangent going to be positive? Nope. So it's just cosine theta. So we don't have to think through the x's and y's every time. If we just know this, we're good. And here's how you can know this and hopefully not get it mixed up. There's a little phrase here too. All students take calculus. Okay? So in the first quadrant, they're all positive. That's where the A for the all comes from. Students, second quadrant, take, third quadrant, calculus, fourth quadrant. So when you're trying to think through your quadrants, that's what you want to think about. You could even write this down because that tells you positive in that quadrant. So if I ask you for the cosine of a third quadrant angle, is it going to be positive or negative? Negative, because only tangent's positive in the third quadrant, right? If I ask you for a cosine value of a fourth quadrant angle, it'll be positive because cosine's positive in the fourth quadrant, okay? So if you just remember all students take calculus, that'll help you with that. So once you get the first quadrant down, the rest is a piece of cake, like I said. Because if we get 7 pi 6, then I want the sine of 7 pi 6. I use my reference angle. Pi 6, the sine of pi 6 is 1/2. And I think, okay, is sine 7 pi 6 is in the which quadrant? Third. 7 pi 6 would be in the third quadrant. So in the third quadrant, is sine positive or negative? Negative, so I just make that 1/2 negative, and that's my answer. Okay, so if you really get the first quadrant down, everything else is based off the first quadrant. Okay, are we good? All right, so I'm going to give you another sheet of paper. I almost wasn't, I printed this and then I was like, you know what, I don't think we really need this because we've been writing it so much on our own, but then I had it, so I decided it's not going to hurt to do it one more time because the repetition should hopefully help. And tomorrow you're going to have a quiz over the first quadrant. It'll look a lot like what the first thing that you did here. First quadrant, sine and cosine values and the angles. So if you could do that today without a problem, you'll do fine on the quiz tomorrow. Okay. All right. So now let's look at this unit circle reference here. I put the degrees on there, or I left them on there, but we're not really that concerned with the degrees. In just a second, I'm going to have you fill in the radian measures, but I want you to look at the blank ordered pairs I put on there because I put the denominators on all of the angles that are not quadrantal angles, because the quadrantal angles, it wouldn't make any sense. Because I want you to see, without anything else on there, that they're all over 2, okay? And all the ordered pairs are sine or cosine. So if it's not a quadrantal angle, then it's something over 2, and you don't have to remember, was it over 3 or was that one even a fraction? They're all fractions and they're all over 2, okay? We good? So go ahead, I'm going to give you a little bit. I want you to fill in everything on this circle. Fill in your radian angles and fill in these ordered pairs. It'll go quicker than last time because the little parentheses and their stuff are already there for you. Is this getting easier the more times you do it? Hopefully it is. And you notice that it's going to be real hard after I've made you write it so many times for you to forget what the numbers themselves are. Maybe you put them in the wrong place, but don't start making up new numbers that we don't have in place, right? There's not that many of them. Oh, shoot. All right. So here's what you should have. You can even check it with your other one. Hopefully, I didn't see any of you just copying from your other one. So good job trying to dig it out of your brain there. Yeah, I didn't even think about that. Good. All right. So we good on that? We just have it written down one more time. We just want to make sure it's right. So if you do go back and look at it. And then I want to talk about this stuff down here at the bottom. So let me make this bigger and scroll. Okie dokie. So we have, it says the positive trig values in these quadrants. So remember, we can make our little coordinates and say all students take calculus. That means that in quadrant 1, they're all positive. What does that mean for quadrant 2? What's positive in the second quadrant? Sine. So this is sine theta. And what's the reciprocal of sine? Cosecant. Very good. Cosecant, because there has to be a co in each pair. So cosecant, which we talked about a little bit. We haven't really talked about them. That's because we got to get all sine, cosine, and tangent down before we start throwing the others in. Then it just gets really boggled in your mind. All right, quadrant 3. What's positive? Tangent. So tangent theta. And then what's the reciprocal of tangent? Cotangent. That one's easy, right? Then in the fourth quadrant, we know all the cosine values are positive. And the reciprocal of cosine is secant. Very good. All right, so the values. So we do know that we use sine is y in a unit circle, but in any circle, it would be y over r, and it ends up just being y in the unit circle because the radius is 1, right? We're just going to kind of generalize it here. That means cosine would be x over r, and tangent is y over x. And that's true in any of them, because if I did y over r over y over x, if I did sine over cosine like that, that gives me y over r. Oh, that's a 4. My goodness. Y over r. Oh, I put y over x. Golly. Okay. I can't write or. Let me back that up. If I'm going to put sine over cosine, which is what I'm trying to do, y over r over x over r. That is your sine over cosine. So y over r times r over x then, and that's where you get your y over x. So that's the same whether it's a unit circle or not, because the radius just is irrelevant. All right, so then what would cosecant be then? R over y. And cosine would be r over x, and cotangent would be x over y. Okay. We good? All right, so tomorrow you're going to have a quiz. First quadrant, you better know your radian angles and your sine and cosine values for the quiz, but then I also want you to make sure by tomorrow you really know your first quadrant tangent values. Okay, it won't be on the quiz, but make sure you know them. I have Quizlet flashcards that I'm going to share with you. I'm probably going to send them to you through Remind and put them available in Schoology so that you can practice like what I'm doing at the door with you on your own. All right, your assignment is in Delta Math. It's much like your last one, but you got to just keep on practicing. This is one of those things that drill and practice. And most of the time, you know, we do a lesson, the next day it's a new topic or it's just an extension of the day before. We've been doing the exact same thing for days, right? Does that tell you how important this is? I hope it does, because it really is.